Good afternoon, dear participants, to this interesting workshop. With my short presentation, I would like to bring to your attention the legacy of the oil and gas industry to the rising seabed mining industry in terms of approach to the management of risks and the protection of the environment. In fact, the oil and gas regulatory system have been recently largely improved, resulting with a high degree of safety of the offshore installation and consequently a sufficient control of the environmental impacts associated to the oil and gas operations. This happened in particular over the last decade or so. The starting point was the Deepwater Horizon incident occurred in the year 2010 in the Gulf of Mexico, where the drill ships of Deepwater Horizon caused a very large environmental damage to the local marine environment due to a massive oil spill in approximately 1,500 meters of water depth. In fact, after the blowout of the Macondo well, generated by a sequence of numerous errors which led to a failure of the safety equipment on board the drill ship, all the most important oil producing countries and the Oil Industry Association reviewed completely their safety policies and procedures by implementing a new modern approach to the risk assessment and the risk management. And in order to reduce the risk of environmental damages on the marine environment, the EU Commission has contributed to this deep review of oil and gas offshore safety issue by unifying the best risk management approaches developed in the EU key producing countries through a pool of experts from all EU member states, to which I have been honored to participate. Going to the point, we can say that the oil and gas legacy can be split into two main branches: deep water technologies and the cultural and strategic approach in environmental risk management, which is the main topic of this presentation. So, what makes the difference between the oil and gas industry and the seabed mining industry? In general, we can say that oil and gas is a mature industry. It has long-standing history records. Their activities are standardized, as well as the key environmental issues have been addressed, and the best risk management approach methods have been properly codified. Unfortunately, this may not be true for the deep seabed mining. In fact, as of today, the seabed mining still does not represent a consolidated industrial activity. Therefore, we are not surprised if substantial differences do exist when we compare the potential environmental effects of the oil and gas exploration and production activities with the analog seabed mining exploration and exploitation activities. For instance, the routine operations are subject to generate different grades of environmental effects if we are dealing with oil and gas or with seabed mining. In fact, a modern oil and gas installation might be generally considered a low impact infrastructure. But the environmental risk increases significantly if we talk of potential impacts on the environment associated to the seabed mining exploration and production operations. On the other hand, we know that oil and gas incidents may still cause significant oil pollution, probably because of the nature of the substance treated. While we still do not have a clear understanding of what the potential incidental scenarios associated to the seabed mining and their environmental consequence would be. In few words, Risk management approaches derived from the oil and gas industry may be a useful means to properly assess the environmental impacts affecting the deep water ecosystem. The risk management approach and the risk assessment are certainly not brand new concepts, and the vast literature is available on the subject. So we are not interested in the details of such methodologies. Instead, we are definitely more interested in the outcomes that such approaches produce in the oil and gas industry. A variety of risk management approaches may be applied at operational level to address both planned and unintended environmental impacts. The list on the left side of this slide includes a summary of the risk management approach adopted for the oil and gas sector and, in our opinion, equally applicable to the seabed mining sector. So the message is, please do not reinvent the wheel and make full use of the methodological approaches successfully developed for the oil and gas sector. This to develop a seabed mining specific risk management approach aimed at reducing the industry learning curve and at promoting the effective protection of the marine environment. This list includes specific items very familiar to the specialists involved in the risk management framework. We will not go into the details, but we just go quickly through this list. Environmental baseline and environmental impact assessment are certainly the key tools to achieve a thorough assessment of the environmental impacts associated to the seabed mining operations. Of course, the more complete environmental information and data set, the more accurate and reliable the evaluations will be. Equally, the ENVID, in other words, the environmental hazard identification, is the most efficient tool to undertake the environmental risk assessment process. Then we have all the specific risk management approaches, like the BAT, best available techniques, or the ALARP review, as low as reasonably practical. Safety and environmental critical elements, we have the safety case and critical aspects. We have the performance standards and independent verification, till the end of the offshore operation to the close down of seabed mining operation and environmental monitoring pre, during, and post mining activities. We have just said that environmental impact assessment and environmental hazard identification are two of the most common and effective environmental risk assessment tools available. Nevertheless, their effectiveness largely depends upon the availability of the background data. In fact, an incomplete dataset leads to a not reliable assessment of the anticipated environmental impacts, of their magnitude and their extent. In other words, the lack or inaccurate data increases the risk of inadequate control of the environmental impacts, or even worse, may lead to unpredicted impacts. So, given the tools available, the key factor is to put together a complete environmental baseline, collating data of all the marine chemical, physical, biological components in a unique ecosystemic framework. Unfortunately, this is not the case. The knowledge of a deep sea ecology is fairly unknown. Fieldwork campaigns represent the first way to address this issue. Nonetheless, new tools can be used, in particular if made in conjunction with the research and development departments. How to improve the knowledge of the ocean ecosystem? Very difficult question. Again, the experience from the oil and gas sector may also help in this regard, especially if the risk management approach is properly integrated with more recent new techniques associated to the use of the artificial intelligence. In fact, we can use the artificial intelligence to integrate incomplete or heterogeneous baseline datasets, or where this dataset is characterized by high variability of the degree of uncertainty. Or we can make, through the artificial intelligence, we can make a full use of the existing data that I would have discarded in the classical analysis. Or even more, we can use the artificial intelligence to extend the knowledge by extracting pattern of data to be predictive where there are no data. All these capabilities have been developed within the oil and gas industry. So in the end, what is at stake? For the seabed mining, the risk is that the stakes are high. Here there are three simple examples, not necessarily exhaustive. We can easily predict anticipated and probably very long-term impacts on the deep sea environment. Or we can predict unwanted indirect effects. For instance, potential interference with the deep sea carbon dioxide sequestration process. Or we can generally predict potential unpredictable detrimental effects on the physical and biological aspects on the marine environment. So in other words, there could be a concrete possibility that the unsatisfactory assessment of the environmental risk associated to the seabed mining operations may lead to appeal to the precautionary principle. What will be the implication in this case? The Principle 15 of the 1992 Rio Declaration states that where there are threats of serious or irreversible damage, lack of full scientific certainty shall not be used as a reason for postponing cost-effective measures to prevent environmental degradation. So this might be considered a fairly broad definition. In fact, we expect that all ranges of preventive and mitigation measures will be put in place in the deep sea mining to minimize the residual risks in consideration of the unaccountable value of the threatened ecosystem. It is anyway true that there is not a universally accepted definition of the precautionary principle. Interpretations mainly vary according to the degree of scientific uncertainty that could prompt action by the authorities. The precautionary principle is closely linked to governance. It raises a number of questions regarding risk governance, risk assessment, management, and communication. Furthermore, since precautionary measures are usually applied following a political decision based on scientific knowledge, science policy interfaces are particularly important. Nowadays, I have no idea on how the precautionary principle may be applied to the seabed mining exploitation developments. So we are at the end of the story. That actually is not the end of the story. This is a simple note for those who know the story of the Schrödinger's cat. As long as the box is closed, the cat's state is completely unknown, and therefore the cat is considered to be both alive and dead at the same time until it is observed. Assuming a comparison with the deep ocean environment, we do not want this to be likely the box of Schrödinger's cat. Thank you for your kind attention.